Alright, hi guys. So what we're going to do today is basically continue on with the idea of piecewise functions while also um, expanding on this idea of absolute values. And so this first section is really just more practice on the piecewise uh, notations here. And so what we have here is, we're going to look and it says graph both the y equals x minus 2 for x less than 3, and we also want to graph y equals negative 2x plus 7 for x is greater than or equal to 3 on the same coordinate grid. And so I'm going to start with the first one here, and it says that my slope is going to be 1 over 1, right, because there's the ghost 1 in front of the x, right? And so that means my rise will be 1 while my run is also 1. But my starting point right here, this negative 2, remember that's my b. So I'm going to start right here on negative 2. And so I'm going to go up 1, over 1, up 1, over 1, and just continue in that fashion. Alright, and so let me draw my connecting lines. There we go. Alright, so the second one, I want to start at 7, right? And let me do this one in red. So my beginning point right here, my b, will be at 7. And then my slope right here is negative 2 over 1. So that means I'm going to go down 2 and over 1. So 1, 2, 1, 1, 2, 1, and just keep going. And if you notice, they do intersect here. So let's go ahead and connect all our dots. And so there we go. So the only thing that we haven't addressed here now at this point, which is the inequality notation right here. So what it's saying is that our domain needs to be restricted to only the x values that are bigger than 3. So I look for the x value that's 3. 1, 2, and 3 right here. And so larger than 3 is going to go in this direction right here. So basically I want to erase everything that is going from this direction backwards. And so my graph will actually shrink in size. So I want this to actually start right there and continue on down. And so the other piece that I have right here says that x is going to be less than 3. So I want to pick, I look at the 3 again, and I find where my graph is at x equals 3, and I know that since I want everything smaller than 3, I want my graph to only show everything going to the left. So this little piece here going to the right, I want to actually erase it and make it come down to here. And so let me erase all these extra dots that I have here, and my graph for this function ends up looking like this. And so my next question here is about the graph. So it wants me to describe the graph in item 1 as completely as possible. And why is this graph a function? Well, the first thing we can answer real quickly is whether or not this is a function. So remember, we draw our vertical line, and if I move it anywhere along the graph, it's only allowed to touch that graph one time. And as I do that, it only touches it once. So I know that this is a function. And even here with my inequality, if you'll notice, this says less than, and this says greater than or equal to. And so both of these still make it to where there's no repeating x values. And so why is the graph a function? The graph, I'll make it a little smaller so we can fit it all in here. The graph is a function because it passes the vertical line test. All right. So then the other part of this question is describing this graph. And so this graph, both of these graphs are linear graphs, right? So so the description of this is that both graphs are linear and have a domain of all real numbers So in other words, remember that would be the double R, or the negative infinity to positive infinity, and a range of, and what is the lowest value here? So actually I'm not going to use a bracket because this keeps going in this direction and this keeps going in that direction, right? But they both stop right here. So since they both keep going down to the bottom, I know that I'm going to go all the way down to negative infinity, and then the y value, the highest y value that I'm going to get out of this is the value of 1. And since I had the greater than or equal to in one of the cases, I know that this is going to be a bracket. So this is how you do the first problem, and I'm going to scroll down and do the next one. Alright, so for this this problem number 3, or the second graph, what's nice and convenient here is that they've already taken the liberty to graph this for you. But just so we kind of understand what it is that we're looking at, we have the graph of y equals x squared minus 3 for x is less than or equal to 0, and y is equal to 1/4 x plus 1 for x being greater than 0 on the same coordinate graph. And so what I want to do here is just take a moment to show you the graphing calculator and how this looks. So if we move this over here for you guys to see. So as you can see, I've put in both the quadratic function and the linear function in here, and I hit the graph button. And when I do, I actually end up seeing this, which doesn't match up with my graph completely. And that's because of the domain restrictions in here. If you notice, this said that we want x to be everything smaller than or equal to 0, which is why this piece right here is no longer, this second half of the quadratic is no longer visible to us, because I look at where the x value is 0, and then I just start erasing everything to the right of that because it's no longer available to me. The domain restriction has told me that I want everything less than 0. And so, here, let me go ahead and erase this a little bit here so I'm not messing with this graph. Okay, and so then the second piece that what I'm told for is I want to look at for when this linear piece right here is everything greater than 0. And so again, I look for x being 0, which is right here at the origin, and I move up to where I finally find my graph. And then since it says everything's greater than, I only want to see everything to the right, so I want to erase everything to the left. And so I'm only left with the half of the quadratic along with half of the linear, which now it matches up with my graph over here. So it's asking us now to give a description of this. So again, we've already taken the liberty of describing most of this while we've been talking. You know, the first graph we said is a quadratic, right? So graph 1 is quadratic, while graph 2 is linear, right? With a domain and range, or how about this, a domain of, and let's actually look at what the domain is. Okay, so this has x values, and because of the arrow, remember, it keeps going in this direction. So my x values are basically all the way out to -infinity, and I continue to look, and right here I have a closed circle, and that fills in this open circle that I have here. And so it continues on, and it continues on in this positive direction all the way up to positive infinity. So my domain is all real values, and my range, so a domain of -infinity to positive infinity, and a range of, and so here's where we want to look. So the lowest part of this graph is down here at -3. So I'm going to put -3. And the reason I put the bracket is because I have this closed circle here. And even if, and so if I didn't have that closed circle, then I'd have to put the parentheses. But I know that it was a closed circle because it told me less than or equal to, and that's what went right here. And this less than right here would be the open circle that goes right there. So the range is from -3 all the way up to, and since this graph continues to go up, positive infinity, right? And so the other question is, does this pass my vertical line test? And so let me go ahead and erase all this extra stuff over here. And let me draw my vertical line. And I start moving it around. Now notice right here it touches the graph twice. But this is actually still okay because one end is an open circle while the other end is a closed circle. So there we go. That is so weird. Okay, so let me draw another horizontal line. So there we go. Now, alright, so as I look right there, my vertical line does touch those two dots, but because one of the dots is closed and the other one is open, that actually means that I only have one x value for 0, and that's right here, down here at -3. And then everything to the right is still everything to the right is still good, and then everything to the left is still good. So this is still a function because it passes the vertical line test, and especially right here at 0, I have an equal to 0 and I have a greater than 0. So basically this covers the double zeros. I do not have that. So, alright, so this is also a function because it passes the vertical line test. Alright, so let's move on to the last section of your notes, and then we'll be done and you guys can get started on your classwork. Alright, so what we have here is basically just a little bit of vocabulary and more of a standard. So whenever we are doing piecewise functions, you guys are not just writing two separate equations, one side on the left and one side on the right, but we're all putting it all together. And so what this is here, it says the functions in items 1 and 2 are called piecewise defined functions. And piecewise functions are written as the following. So this is the function, so the function name, and then this big brace is what connects the two equations together. So this is just notation saying that these two equations are together. And so remember, this one was the problem number 3, and this also kept the domain restrictions in there. It says that this graph is only usable as long as x is anything smaller than or equal to 3. And then if it is bigger than or equal or bigger than 0, did I say 3? I meant 0. Less than 0. And so here, anything bigger than 0 is going to use this particular function. So if we wanted to complete this table that we have right here, it says that x is -4. So since on this graph we're told that -1 is kind of the catalyst point here. I'm going to look at anything smaller than -1. And so this one, and this one, all three of these go to the first equation right here because my x value is smaller than -1. And so I can take my calculator and just kind of plug in what I need. So I'm going to clear this. So the first one that we have is -2 parentheses -4 minus 2. And so my first value is going to be 6 right here. And then I keep going down the line because remember, everything that I'm using is, as long as my x value is -1, I'm using this first equation right here. And so second and enter will repeat it, and so I can just change the 4 to 3. And so that's going to give me 4, and -2 will give me 2. So I know that this should be 4 and this should be 2. And so now that I've gotten a -1, I'm going to use this equation because all of my values are going to be greater than or equal to -1. And so I just come through here and I go parentheses, let me make sure that wasn't a negative, okay, parentheses, -1 plus 3 gives me 2. Do the same thing, except now instead of -1 I'm using 0, which gives me 3. I think we can figure out the pattern from here. I'm just increasing by 1, right? So 2, 3, 4, and then lastly is going to be 5. And so when I graph both of these, the first one, -4, 1, 2, 3, 4, +6 right here. Second one, 3 and 4, or -3 and 4, -2 and +2. Now the next one, -1, also gives me it gives me +2, and then 0 and 3, 1 and 4, and 2 and 5. And so as you can see, I'm going to basically have this right here, and then it keeps going until I get to the point of -1. And if I were to continue in this pattern, I'd go down to and over 1, so this would actually come all the way down to here with an open circle, while this starts with a closed circle and goes in this direction. Alright, so I continued on down with my slope of down 2 and over 1, down 2 and over 1. But why did I put the open circle at the bottom of this one? That was because this had just less than. So let's go ahead and see what the questions are that we have down here about this. Here. Alright, so it says the domain of the piecewise function consists of the union of all the domains of individual pieces of the function. So likewise, the range of a piecewise defined function consists of all the union of all the ranges of the individual pieces. So what is the domain and range of g of x in item number 5? And so let's go ahead and put our table back up here real quick. And so the domain is going to be, in this particular case, the domain will be -4 to +2. And the range, if you look, is the lowest value for this is actually where? Down here at 0. But because I have the open circle, I need to put the parentheses in there. And so then this goes, for this particular example, goes all the way up. The highest value is going to be 6. Now, with a bracket. Now, if domain, then range. Alright, so If I were to actually look at this though, adjust at the equation, knowing that these continue on in both of these directions forever, I know that I could say that the domain is going to be also from negative infinity to positive infinity, and that the range will be from, again, 0, but instead of 6, because I know it continues up forever, we'll go to infinity. And so let's see which one of these that the question actually wants. Let's read it again. It says, what is the domain and range of g of x? So g of x would be this entire function right here. So even though this is great for the table, this is not really what they're wanting. So let's go ahead and delete that. Or not. Let's just move it. Alright. So the domain and range that they're asking for then is this right here. And that would be more found looking at the graph than it would be at the table. Alright. So let's go ahead and see what the last little bit of this says. It says, another type of piecewise defined function is called a step function. One such function is the greatest integer function. So we've talked about this one. This is the one that looks like a step, right? Which yields a value of f of x that is the greatest integer less than or equal to the value of x. For example, if I have 2.7, the greatest integer, the integer being the number, the whole number in the front, is 2. And so if I take another example of negative 3.1, the greatest integer of that is going to give me negative 4. Now why did this go down to 2 and this go up to negative 4? It says because the greatest integer less than or equal to negative 3.1 is negative 4. So because it's the greatest integer less than or equal to, so what numbers are less than negative 3.1? The next number that's smaller is negative 4. Just like the next number that was smaller here for the 2.7, the one that was smaller would be 2, not 3. So one step of this function is graph to the left and then complete. So we want to complete this particular graph. So if I were to do that, I know that the next one is a complete circle going all the way to 3 with an open circle. Come up to the next one, closed circle, go to the 4, open circle. And so you just continue this pattern forever. Okay? Alright, so you guys, your task will be to work on the next sheet, which is starting at problem number 7. And that's what we're going to be starting on when you guys get to class tomorrow. Have a good night.